Hello there. Thank you for joining me today. What we have here is a differential equation. dy dx is equal to x divided by the square root of x squared plus 16, where we know that the y value when x equals 3 is equal to 1. So the goal is to solve this differential equation, which means we're trying to find the function y that satisfies all these conditions. So if dy dx is equal to this expression, that means that y is equal to the antiderivative of this expression. And this is what's going to get us the indefinite answer, the general answer, the family of curves, and then we apply the initial condition to find the value of c. So that's kind of our framework here. So the first thing to think about here is remember that whenever we see a square root in calculus, we always write it as a 1/2 power. And since this one is in a denominator, it's really a negative 1/2 power. So that's going to be where I start here. And then it looks like we have a complicated expression to the negative 1/2 power. So I'm going to call that u equals x squared plus 16. And that means the differential form is 2x dx. And since I don't have the 2, I'm going to isolate x dx. So that means this piece. So this means that x dx is equal to 1/2 du. Just divide both sides by 2. Okay, so looking at that now, so x squared plus 16 is u. So it's u to the negative 1/2, and the x dx, that all becomes 1/2 du. So I'm going to put the 1/2 here and the du here. Okay, so remember that constants can come outside, so I'm going to put the 1/2 outside, u to the negative 1/2 du, and then we use our power rule. So this is 1/2 times, now going up 1 power is 1/2, and I divide by 1/2 right away, plus c. And a couple ways to handle this. I could either bring the 1/2 up as a reciprocal, make it a 2, and then the 2 and the 1/2 would cancel each other out. Or if I just multiply my fraction straight across, that's a 1. So either way, I just end up with u to the 1/2 plus c, which is, well, we could write that as the square root of u plus c, just to make it more familiar, which is the square root of x squared plus 16 plus c. Remember, that's all y. Okay, so the family of curves that solves the functional part of the differential equation is y equals square root of x squared plus 16 plus c. So c could be any constant at this point. We want to know the particular one where 3, 1 is a point on the curve. So that means when x equals 3, y is equal to 1. So we substitute 1 for y, we substitute 3 for x, and we see what happens. So 1 is equal to square root, 3 squared is 9, plus 16, plus c. So you have 1 equals, 9 plus 16 is 25, and the square root of 25 is 5, plus c. So that means that c is negative 4. So that we're almost at the final answer. So taking this is where we started from. The final answer is y equals square root x squared plus 16 minus 4. And I will share this with you. A lot of times there is confusion about where the square root starts and stops. So it is often customary to write the constant first, followed by the square root. That way you know that 16 is the last thing intended to be under the square root. Otherwise, somebody might think that the minus 4 is also under the square root. So that's just a little tidbit of information there for you. But there's our solution to our differential equation, the function that satisfies both the condition about y of 3 equals 1 and dy dx equals, as we saw up here, x divided by square root x squared plus 16.